All right, let's get started here. Make sure that the stream is running. All right, let's get. Okay, so stream's working. So I'm just doing a little bit of work here. So a couple goals is work on Debian Autobox and work on. So Debian 13 was just released. So Debian is one of the more popular Linux distros, and lately I've been thinking about like trying to find a distribution for network automation to use, because I generally don't care about the operating system. I don't care about Windows or Linux or FreeBSD or any of the BSDs. What I care about is what is easy. And right now, Linux is easy for doing network automation. You could do network automation in Windows, but it's kind of a pain. There's extra steps that you have to take that you wouldn't on a Linux system. Same thing for FreeBSD. So I just want something that's easy, that's going to be flexible and have a lot of good documentation for. And documentation is things like, are there guides online that I can, like if I want to install like InfluxDB, are there guides to do it? Or one of the things I use a lot is Code Server, and I have not been able to get Code Server installed on FreeBSD, but it's super easy. It's barely an inconvenience.
Actually, it's going to be super easy, barely an inconvenience.
When we're talking about on Linux, because it's really easy. So when I first started out doing what I call the Autobox, and the Autobox is a system that has all that you need to do network automation, including network operating systems. So, what is Autobox? So it's an all-in-one VM. So let's do all-in-one VM. So if you can make a virtual machine with 4 vCPUs, 16 gigabytes of RAM, you can do Ansible, Code Server, Arista CEOS, and Container Lab. And it's an all-in-one place where you can practice network automation with Arista CEOS. And I chose Arista CEOS because it's the lightest weight of the various network operating systems that you can do in a virtual environment. They barely use up any CPU if they're idle. And even when they're like doing EVP and VXLAN, they use a very little CPU. And they only use up about 1 gig of RAM per node. So you can actually build out a pretty decent leaf and spine topology. So 3 spines, 4 leaves, a couple endpoints. Not really the problem, but the thing is like what VM do I instantiate? So initially, when I did this is based off of Alma. So look up at the Alma Linux. Trying to get an Alma logo. There we go. So it was Alma Linux. And initially it was Alma Linux 9, and I moved it to 10. So I'll make this text bigger here. Put a little arrow. So yeah, that was Alma Linux 9. And then I thought, okay, so Alma Linux is a downstream of Red Hat Enterprise Linux. So it's in a family of, I don't know where I'm going with this, by the way. I'm just kind of talking, just kind of goofing.
I'm just goofing. New boot goofing. Oh!
Linux for network administration. And so I don't want to care about the Linux distribution. I want something that's going to be easy. But I do have to put some thought into like, okay, so which Linux distro am I using? There's like hundreds of them, but there's actually only a couple of them that are probably good for network administration, for doing automation, jump boxes, backups, that kind of thing. So there's only a couple that are probably good ones. So one of them is Alma Linux. And there's also, well, let's do another one for Linux distro families. So Linux isn't just Linux, of course. If you're a network administrator, you may not be aware of this. I think most of you probably are, though. Linux is just the kernel, and then there's a bunch of stuff around it and how it's arranged, and where stuff is put, and how things get started, where the config files are. And every Linux distribution is different, but they're all kind of come from the same family. So one of those families is Red Hat. So I'm looking for a good Red Hat image here. So RHEL. No, I never recommend, well, not never, but in most of the time I don't recommend using Red Hat Enterprise Linux for network automation. And the reason is that you have to pay for it. And even if it's, and it's not just the paying for it part, you have to keep it compliant. So whenever you're doing any kind of licensing, there's an administrative overhead for doing license compliance, and making sure that you're complying with whatever the license is. And like right now, I think you can get 16 images of RHEL for free, but I don't know if they are for production or not. And if they are viable to use for production, even though you're not paying for it, like what happens if they change their mind? Like Oracle is kind of famous for this, of like having free stuff and all of a sudden they start changing. It's called rug pull. Red Hat has done that. They did that with CentOS Linux. So I never recommend RHEL for network automation, just because of the overhead of the license compliance and all that goofy stuff. I mean, if you want to pay a couple $100 a month for a RHEL, or a couple $100 a year for a RHEL subscription, what even is it? So RHEL subscription. Like what do we pay? It's like $384 a year. Yeah, no, thank you. So, and that's self-support. That's not even like, I can't even call Red Hat if I get a problem. It's $383.90 a year just for the privilege of running RHEL. And so I just don't think there's any value in it. There may be industries, if you're like a financial or a medical, you probably do have to pay for your RHEL, and you'll probably have a larger allotment that you can do, and you're already dealing with the whatever, and that's fine. But if you don't know that, if someone hasn't told you we have to use RHEL, then my recommendation is don't. So that's why I never recommend it. I don't necessarily say don't use RHEL. I'm just saying, like, do you need to use RHEL? I'm still salty about the CentOS Linux thing. So there's also CentOS Linux, or there was. There's not anymore. There's CentOS Stream, but it's not CentOS Linux. Okay, and then there's a CentOS stream. That was the whole thing. Yeah, generally don't recommend stream. For a couple of reasons. The way it's positioned is, I mean, they straight up say this is not for production. That's what Red Hat says. They've said it a couple of different places. Stream is basically meant to be, so if you're using, can't find one that actually says stream in it. There's also Rocky Linux. So they say, is CentOS stream for production? So this is back when they were doing that. Yeah, so CentOS stream may seem like a natural choice to replace Linux. That's not the only place that they've said this as well. Is there actually an author on this page? No, there's no author. So it's just Red Hat. So there's Red Hat Enterprise Linux, there's Alma Linux, and then there's Rocky Linux. So I'm just kind of doing a meandering tour through the different Linux distributions that you might use for network automation. So this is a family that I would call Enterprise Linux. So maybe I'll make this a tech talk. So Alma Linux, Rocky Linux, RHEL, CentOS, CentOS Stream. And I need a Grim Reaper. So the old CentOS is maybe you'll put in a poop emoji. So that's always classy. very salty about the discontinuation of CentOS. I wouldn't even be having this conversation if CentOS Linux was still around, because it would just be CentOS Linux. That would be the obvious choice. So the other big family is Debian. There's fewer choices there, which is, I think, good, because it's either Debian or Ubuntu. Those are kind of the two choices there. There's also Fedora, but I don't generally consider Fedora a very good platform for I don't consider Fedora a very good platform for servers. Fedora is more like a desktop, I think, so I'm not going to include it in here. So all of this was started by then we'll do, there we go. There we go. So there's Linux distro families. So there's the Enterprise Linux family, and then there's the Debian family. So Ubuntu is a derivative of Debian. So if you're a network administrator, or if you're a server administrator, or network administrator looking for a Linux distribution, like, what do we care about in a Linux distro? So generally, what do we care about? So we want something popular. And popularity, we're not going to get any points for being obscure, because popularity comes with a couple of things. One, there's lots of documentation. And by documentation, I mean like blog articles, installation guides, search results, and now AI info. So like if I ask, hey, I can ask ChatGPT, hey, what's the best way to do something, and then ChatGPT comes up with it. It needs a lot of source material for it to work. Same thing with search results. So one of the most terrifying places to be when we're in any kind of environment, when we're trying to do some support or find a problem, is we Google the error message and nothing comes up, and that means you're in Google 0. Which is a terrifying place to be. That means that no one else has found the problem that you have, and now it's up to you to solve it. And that's not great. So we care about popularity. We care about stability. So stability is very different than the stability that we think of as a network. As a network, stability is measured in like, how is it going to like fall over, or is the packet going to go from one end of the network to the other? An unstable network, we don't know for sure. But stability in Linux is things don't change when we do minor updates. Don't change much. Things don't break when we do minor updates. So the life cycle of most distros today is we want a stable life cycle. So we want a release that's going to last a couple of years. I would say at least 2, but no more than 5. And there's a reason why I don't want more than 5. I'm of the opinion when we put any kind of workload on a operating system, we should be planning for the next operating system we're going to put it on. So we should have the instructions on how to extract that workload and put it onto a new system. Because I think in IT we have not done that enough. Because when we don't think about that as we go along, then we end up with Windows 2003 servers still in our data center, which is very common the case. It's very late in the game, but I'm prepping right now to move to Windows 11. Not because I don't like Windows 10. I would kind of wish that Windows 10 would be around for a while. Because while I like Linux for the server, I don't necessarily like Linux for the desktop personally. Mostly because the apps that I use, I use Premiere Pro to edit videos, and then I use Lightroom to edit photos, and neither of those have very comparable options in the Linux world. So it's either Mac or Linux for the desktop for me. Okay, so stable life cycles. We care about stable life cycles. So, for example, this is Alma 9. Alma Linux 9. Alma Linux 8. Alma Linux 10. So there's overlaps. So do the Alma lifecycle. Maybe an image I could just... Yeah, these are released timelines. Okay, yeah, this is what I want. So active support is 5 years, and that's really what I care about. There's also extended security support. I mean, if you can't upgrade your stuff in 5 years, I think you're doing something really wrong. So I'm going to edit this video title. All right, so I edited the video title, so it's Linux Network Administration. So we got May 2025. Make a little itty bitty arrow. And then
A is for Apple. A always stands for Apple. There's nothing we can do about that.
so this one started May of 2022 for 9, and then March 2021. So just finding some starting points for these. Are these all the same size? Yep, they are. So these are what they call active support. I think as a network administrator, you should just concern yourself with the active support era. It's 5 years. That's plenty of time. I think you should probably be upgrading every like 2 years. So this one is 2027. And 8 is coming end of life. I think next, well, not end of life, but end of active support, like sometime next year. Yeah, May 2024. Oh, it's already end of active support. Do they not do 5 years? That's Alma. Oh, that's right. Alma 8. When did RHEL 8 come out? Alma came out in March of 2021. That's why. So May of 2019, that's why. So there's overlaps. Yeah, that works. Okay, so stable life cycles. So, so like RHEL, let's put a RHEL here. Well, I'll do Alma. That was 21. Okay. So stable life cycles, what we want to do is we want to jump from one to the other. We want to migrate from one to the other as the need arises. So a couple of guidelines. Let's put some guidelines. I'm just thinking out loud here. There's not for another perhaps class that'll do. So stable life cycles, Linux system life cycle. We network admins don't need more than 5-year cycles. So RHEL is crazy because RHEL knows who pays their bills. Red Hat's, they have a lot of customers who are enterprises, and enterprise applications are like ticks. They dig into a data center, they don't want to come out, and they don't want to ever upgrade the operating system. So they have 10-year life cycles, and they actually even extended. So if you pay them even more money, just like with Microsoft, they'll keep really old versions of operating systems around for like 13 years, I think, in some cases. And it's kind of like Microsoft will do that with, I think Windows 10 is being deprecated in October next month, or in 2 months rather. And then, but you can do an extended support. So you'd buy a support contract and then they'll give you updates beyond that. So Red Hat will do that too. I think up to 13 years or something crazy like that. There's no way that you should do that. So we don't need more than 5 year cycles. So, and then when we install apps infrastructure, part of that plan should be the next operating system. So we should be planning. So I've moved to Alma 10, or I've moved to Debian 13, or I'm moving to Debian 13, but I've also got in my head like what happens when the next version comes out. I mean, we don't necessarily need to like install it right away on May, like Alma 10 is May 2025. Most of the time we're going to wait a few months to make sure that no one else ran into some weird bugs, because there's usually some kind of new bug that comes out. Whenever a new thing comes out, as soon as it gets mass consumed, that's when the bugs come out. But whenever we install apps or infrastructure, part of the plan should be the next operating system, the next platform. So let me make a be portable. As much as you can, be portable and be portable in a way that you can move from CentOS to Ubuntu, or Ubuntu to Debian, or Debian to RHEL, or whatever it is. But we want to be portable, because we want to have the OS and we want to have our apps. And we want them to be different enough that we can migrate them so that we have an old OS. We in the enterprise are very, very bad at this. But if you're doing network automation, it's actually very easy to be this way. It's actually, it's very easy to migrate from one platform to another. If you do a little bit of planning ahead of time. This is not super difficult. What we don't want to do is we want to have a nice delineation. What most of the is there a way to do? No, let's just do this. Most of the time, we integrate the apps with the OS in a way that makes it difficult to extricate themselves. But again, in network automation, the way that we install software, the way that we consume software, is typically some sort of automation platform. It should be relatively easy to migrate to a new platform, but you got to plan ahead of time. So that means you're not just doing an installation; you're doing an automated installation. Automated installation. Put the wrong emphasis on the wrong syllable. So that we can do this easily. So what will happen typically is, let's see, format shape. We want to avoid the gradient here. So this will be orange. And this will be that dark blue. Remove that. Oh, that's, yeah, add, remove. There we go. It takes some extra work to get to this point where we can migrate from the old platform to the new platform relatively easily. But we want to avoid is the mingling of the app in the OS that it's installed on, to the point where this right here, when we mix the apps in the OS, that's what most enterprises are running. That's why we have like Windows 2003 servers still around. So we want to avoid that. So let me do the universal symbol for don't do this. Yeah, if they blend together, it's like mixing flour and sugar. If you're like making a cake or something, like it's very difficult to extricate the two. So we want to be portable. And how to be portable? Don't install, automate the install. So automating the install has two processes, is figure out how to do it manually, figure out how to automate that task, and then have that automation ready so that when we migrate to the new platform, it's relatively easy to do so. So that's kind of what I'm doing right here. So what I'm doing here is I've got a new Debian 13 system and I'm building this as a template so that I can just install any that I need to. I can use Ansible just to spin me up a new VM. So this is 229. So what am I doing in terms of like, so it's my automation, Linux automation system. So the couple things whenever I'm installing a Linux-based automation system, there's a couple things I need to do. I need to pick a Linux-based OS. And again, Linux because it is the easiest to work with. Not so much because Linux is easier than the other operating systems, but the friction is less. So if I want to install Python on Linux or do Python environments or update Python on Linux, it's easier to do it than it is for the other operating systems. Installing Ansible is easier in Linux than it is for the other operating systems. You can do it, but sometimes it'll take you a lot longer to do it. Like,
I'm not quite sure how to help you with that.
Like I was trying to install Ansible on FreeBSD, and it ran into some problems, and I had to like Google a bunch of stuff, and I got it into a weird state, and then someone said, "Hey, do this," and finally it worked. But it was a big pain. Whereas on Linux, it's what I would say would be...
Actually, it's going to be super easy, barely an inconvenience.
So we want the least friction. So we're going to pick a Linux-based OS. Then I'm going to install... there's going to be a system Python, and then I'm going to install Python, and I really try to, and Python environments. I really wanted to avoid doing Python environments, but I couldn't. There's just too many systems that require Python. Too many system utilities that require Python to be a very specific version. So then you end up with really old Python. So I really tried to avoid it. So leave system Python alone. Use Python environments. And I'm looking at like UV is a new way to do it. So VMs, pipx, and then UV is another one. So different ways to do multiple Python environments, because there's a system Python, and some system utilities require that you keep that Python, whatever it is. And then there's the Python that you need to do for Ansible and stuff. And oftentimes that needs to be a newer Python than your system. But if you're at the beginning of a system's whatever, then you're going to be okay. So, for example, this is Python 3.8 for Alma 8, and that's just because of what RHEL does. And this is Python 3.9. I think this is Python 3.13. Let me go to one of my newer systems. Do I have a... yeah, Autobox test. So this is one of my Alma 10 systems. Drinking gas station coffee. So Python 3 version 3.12. Okay, so it's 3.12. And it will probably be 3.12 for the entirety of the life cycle of Alma 10, but 3.13 is out. But all of the scripts that the system uses for management, for example, Firewall D is probably the best example there. So this is something I learned. Stability example. So one of the things that I did let's move everything over a little bit. So when I had the Autobox instructions based off of Alma 9, Python 3.9 is what they use. So like I've got a system here, Autobox. So this is my 80 gig version of it. If I do Python 3 version, Python, it's 3.9. And it will be 3.9. The built-in Python for Alma 9 will be that forever. And if you do firewall D, for example, command, or is it firewall command? Yeah, firewall command, that is based off of Python 3.9. So if I tried to upgrade it to 3.12 and it didn't work, but some of the Ansible stuff may require a newer version, like Arista AVD, the collection for that, for Ansible, requires 3.10. So then I have 3.9, and if I upgrade to 3.10, it breaks a bunch of stuff on Alma 9. So that's why you need Python. That's why you need Python environments. I really tried not to do Python environments, but because I wanted to keep it as simple as possible, but it's impossible. It's kind of a pain to work with. All right, I install Code Server. So Code Server is VS Code running as a web app. I love Code Server. It is my absolute favorite. One of my favorite tools to use in server administration for network admins. So I'm going to go to HTTPS. So this is Code Server. And it's like VS Code, but it's running on that Linux system. So this is a Linux system. This is the development environment I'm using for my EVPN book. And so this Linux system is, excuse me, is is running a code server. So I've got a file editor, file browser, and I've got a terminal window. So rather than SSHing in through like an SSH client from my Windows system or my Mac laptop, I just go to the web browser and then I've got the entire system. I can do everything on there. So that's my favorite way to do it. And there's a couple things you need to do on code server. As install code server and then set the password using Argon 2. So pick a Linux based OS, install Python. What else do I do? Install Ansible and any collections you need. So let's, so this system right here, Debian 13 template, I don't think I have code server installed. No. So what I need to do is install code server. So from here, this is 229 for me. So SSH. So there's a couple other things I like to do. So you notice this prompt here is really fancy. It's called ricing. So when you rice up your Linux environment, you can do all sorts of cool like ASCII and ANSI graphics and stuff. So I need to figure out how to do that because I want to use that shell and ZCSH. But anyway, yeah, I have not done that here yet. So I'm building this as a template. I do need to install code server. Code server is pretty easy to install on Linux. I've not got it to work for FreeBSD. I both like and dislike FreeBSD. I dislike it. The only reason I dislike it is because you have to do so much extra work and there's no advantage. So dnf-y install curl. I don't even have sudo in here, or oh, it's Debian. That's why sudo apt-y install curl. Okay, so if I do that. All right, so we need to do sudo system control enable. Oh, we need to do some post install stuff. So I have a whole like set of scripts here that I run. So I need to install this stuff. I'll just copy and paste it. Was it all pip? I don't need to do pip. All right, so we did that. It's all code server. And then this right here, because we got to do a couple of things. I should have asked, oh, bash install. Yeah, so once I need a password, so I'll do my normal one. So code server. If you want to do a hash password, you have to make one. Otherwise, it stores a password like this. But I want it to be encrypted. Okay, so that's code server. So I should be able to get to the system now by itself. So 229. Let's go to 192.168.1.229.80.80. And there we go. And let me in. Or sorry. The password I set. Which one did I set? All right, so this is code server. On that new Debian, so this is Debian 13. And I will... So I need to do a theme. I want to do a color theme, dark. Okay. So again, what we don't want to end up is we want, I'm not going to set this thing up manually. Well, I'm going to set it up manually first. And then I'm going to set up a shell script that's going to configure it dynamically or configure it in an automated way, because that makes it easy to migrate from one platform to another or have a system like that. And then I also have this setup TLS script. So you see here it's not secure, and that's because the certificate I'm going by the IP address. It used to be that you could just export the cert and then import it into your OS's or your browser's certificate store. But newer versions of TLS won't let you do an IP address for a host name unless you do a SAN or a secondary address name. I think that's what it is. So what I did is I made a script that will generate a self-signed certificate. So I will edit it here. Oh yeah, I need to make a directory called workspace. Oh, it's already there. Cool. So open folder workspace. You don't want to run. You don't want to run VS Code in your home directory because you've got a bunch of stuff in there, like config files and stuff. So I'm going to make this one is going to be setup tls.sh. I think sh will do. And then we're in a terminal. Didn't like something there. Do I have OpenSSL? OpenSSL. I do. Okay. So what shell do I need? Can I do bin sh? When I wrote this script, I forgot and I didn't put it up here. Parse value. So I'm gonna comment all that out. Oh yeah, so I didn't give it a yeah, so I need to put a thing in here. I actually wrote this. I posted something on Reddit. So basically, I need a. There we go. Needs an IP address argument. Okay, so what's my IP address? 229. There we go. So it generated this, and then what I'll do. Oh, okay. So do that again. So now I need to restart my browser. And if I do a certificate details, and I can export this certificate. So this will be Debian 13 template. And then what I'll do is, so that's my certificate. I'm going to install this certificate for my current user. and I'll put it into trusted root cert authorities, finish it, and then I'll quit the browser. Make sure I kill all instances of it. And then I'll start the browser up again. There we go. Was it to... I already forgot what it was. What did I make the IP address? 229. No, it didn't work. Did I have to, do I need to kill all my, because I had another, let's try that again. Nope. So now I gotta fix this. Why is this not working? Oh, you know what? Because I didn't restart the browser. Since I reran the script, I'll have to re-export and re-import. So export, just overwrite it. Kill it, install it. Put it in trusted root authorities, because that's what your browser looks at. Oops. Yeah, so 229. There we go. As you can see here, now it's not complaining about the certificate. There's a couple of functions in VS Code that needs that to be good. All right, so that is good there. Now there's other ways to do like a certificate authority and stuff, but this is like the easiest way to do it for that. Let's see. Okay. So this is that system. Next up for the customization, we do the Python environments. I already have that set up here. So to do that, I'm going to do do source, PyDefault, bin activate. So now I'm in a Python environment, and then I'll do Ansible, or do pip3 install Ansible. Core equals 2.19.1. So I wanted to check some stuff. Because right now Ansible is broken on the latest version of Core. I wanted to see if they fixed it. So Netcommon was broken, but they said there's a fix-in for it. They just released it, so maybe. So Ansible Playbook or Ansible Galaxy install Netcommon force. Netcommon Ansible Galaxy collection list. Eight out of 1. I think there's a newer version. What are we at? Yeah, updated 12 hours ago. Yeah, I'd say there's a new version. Did I spell it right? Not common. Ansible, not common. Collection, install, Ansible, not common. Maybe I did the command wrong. Cloud.common does not support 219. We'll just force this. Okay, Ansible 8.1 was installed successfully. So if we do Ansible version, Ansible playbook version, we are in core.219. This is the broken one. And we're going to test it out here. So we're going to install all the fun stuff. So I want to install. So I got this installed. Okay, so that's good. And I need to install Ubuntu. Oh, you know what I missed? I missed installing Docker. Use the Ubuntu instructions. So I need to install the apt store, app stuff. I don't have a Trixie one yet for 13. Let's see if this will work. Yeah, so I need to install the Docker Debian. Oh, there's a Trixie. So how did that not... Then have a release file. Then I need to... Let's try this again. Okay, that worked. Nope, that didn't work. That's the bummer about being on the bleeding edge. It's not really the bleeding edge, but... Oh, there we go. I don't know why I did Ubuntu. Man, so I was a Unix administrator in the 90s, and so there was this interesting progression where we did package progression. So in the 1990s, if we wanted to install software, oftentimes we would just compile and tar, then make install. So like Apache, I would download Apache source code, I would compile it on a system, then I would I would tar up that directory, and then I would put it everywhere and then do a make install, and it would have the binaries and stuff on that system. So that's typically how we did it. There was packages in there, and then late 1990s, early 2000s, we would use packages, OS native packages. So that's where you got RPM and apt, or RPMs and Debian and deb files and RPMs, and there was like a Solaris package system. But what really changed the game was the package manager. Was package management. And this would do dependency resolving. Because you would try to install a package and it would need some other packages. So you'd have to get those, and you'd have to get those, and sometimes they were all interconnected. But with package management, you would install one component, it would automatically find what dependencies were and then download those. And so the package managers had a repo, centralized repository where you can get all these packages from, built into package dependency mapping and stuff. You can still get into what we affectionately refer to as package management hell, but it's harder to do these days. It's much better. Okay, so what do I need to do now? I need to do this. Oh, I need to import some Docker images. I need to get the images on there, so I need to do FileZilla. So 229. No, I don't want to install. I'll throw a lab in here. Actually, I think there's a new one on there. Let me download. Did I download it? No. Just a second. Let me get a new version of EOS. Containerized EOS, which I really like. Software downloads. 4342F is out. So that's downloading.
A is for Apple. A always stands for Apple. There's nothing we can do about that.
That's the cloud!
That's Larry Ellison's rant.
A is for Apple. A.
I mean, cloud. They have databases and operating systems and memory and microprocessors and the internet. And all of a sudden, it's none of that. It's the cloud.
Okay, so so for this, I need to run Docker import. Docker import COS lab COS 4.342F. That takes a second. While I'm drinking my gas station coffee. So I used to really like this fancy brand called Intelligentsia. It's a really good coffee brand. It was harder to get, but now it's in a lot of stores like Whole Foods. And it's really smooth. I love the frequency blend. That's my favorite. But whenever I'm traveling for skydiving, I have to stay in rural areas. And so the coffee I get, and I don't really like Starbucks coffee. So I just go to a gas station, like one of those like big gas station convenience store kind of things. And a lot of times they'll have vanilla flavored coffee, like just vanilla coffee. And I get that, and I developed a taste for it. So most of the coffee I drink now is like what I call gas station coffee. So it's vanilla flavored. It's not very fancy, but it certainly hits the spot. Okay, so Docker, and then we need to install Container Lab. So sudo docker image list. So we got CEOS. That looks good. And then Container Lab instructions. Container Lab's really easy to install. Love Container Lab. So that's done, and then I just need to do this. All right, so I can make a so I'll make a Container Lab directory, and then from another place, I'll make a, copying this from somewhere. I was going to make a thing called network as YAML. Just playing around with YAML. I've only got one of these in here, so I'm just going to do 342F. Maybe I can move. Yeah, you know what? I'll do that. Look at things set up and situated here. Make a directory called images. Move COS images. Do I have enough disk space for this? Yeah, it looks like I do. $229. So I'm putting my 9kV image on there. Another great thing about containerized EOS from Arista is that they make it very easy to get a hold of this thing. This is a lot harder to get a hold of. I have a copy from when I was working with a Cisco partner. Otherwise, it has to like fall off the back of a truck. So I'm getting this image here. 9kV. All right, I'll move that to images. And then I'm getting the Juniper C Junos evolved as well. I'm uploading it from another place. I'm going to take a bathroom break. I'll be right back. That was BGP unnumbered. If you're still watching, this is probably something got in the background. I'll be right back. I got more gas station coffee. The funny thing is I'm using a mug from a company called, see if I can focus on that. It was an old WAN optimization company. think I got that mug when I did a network field day event with them like 15 years ago, something like that. Yeah, they're no longer in business, but it's good coffee mug. Oh, it's a little late to be drinking coffee. It's like 6 o'clock here, but I slept in a little bit this morning, and coffee doesn't really keep me awake. In fact, I can take a nap after I've drank a bunch of coffee. And it gives me vivid dreams. That's the weird thing about me napping with coffee. Okay, so move Junos into images, and then we're doing sudo docker load-i, I think. And it'll be 20. Oh, that's the wrong version. That's an old version. Yeah, I did not want that one. That's a CRPD. That one sucks. Nope, we don't want that one. We want C Junos. C Junos Evolved. So that one just came out as a container for Container Lab. Well, you can use it for anything, but it's primarily oriented for Container Lab. It's not actually a container. It starts up a Linux container that boots a VM of Junos Evolved, and it is very heavyweight. Okay. So do sudo docker load-i c Junos Evolved into c Junos evo, and then the version number 2r1.8. Some of the images are loaded by load, and some of are import. I don't know what the difference is between them, but I know if you don't do it the right way, it barfs. Still waiting. Well, that was weird. Okay, and so the Nexus 9KV stuff, that's going to be a little bit more tricky because we need to do something called VRNet Lab. So copy images, x9kv. We'll put that into NXOS 9kv. I think that's where it should go. This copy's happened a lot slower than it should. I'm very suspicious. Why the heck? I don't know why that took so long. Maybe there. It's not titanium, that's the thing. Where do I put it? So it must be NXOS 9kv. How the heck did it work on the other one? Let make install. What is that file? Maybe I need to make here. What's going on here? Still building. Watching paint dry.
I'm just goofing. New boot goofing. Oh!
What the heck is it doing? Okay, I've not run out of disk space. I only give these things like 60 gigs of disk space. Oh, is it doing like a whole like... Yeah, I think it's updating my entire system. What is this part here? I have to Google this. What's a floppy drive image? I don't know why. That's a firmware thing. Oh, yeah. Should read the instructions. I didn't need to do this before. So I need that file. Let's need that EF5 file. I have it somewhere else. I wonder if I can export it from another place, because I have it in another repo. We do image save. Yeah, so let's do another window here. Docker save, Docker save. Okay. Saving right now. I'm exporting in the image. Okay. Almost done here. Done btop. Yeah, so I'm going to create a new directory here for install. Just of some scripts that we need to install for Debian so that I can get this ready. Yeah, we don't want to do any of the pip stuff yet. Oh yeah, this is yeah. Yeah, my Debian install previously had actually like broke the warning of installing Python modules in the base system. Because I was trying to keep things simple, but I think it's just better. Yeah. All right. It's uploading. All right, so sudo docker image import nkv. I don't know if I need to do a -i load though. We'll find out in a second, I guess. Oh, you know what? Yeah, we should access 9K. I'll do that. Oops, nope. There. Ah, crap. Ran out of space. Didn't give it enough storage. Still no. Oh, it's putting it in the root directory. That's why. Crap. It's not putting it at home. So how am I going to do? My problem is the Docker repo is in the root file system, and I just did not put enough in there. I think it's var lib docker. Yeah, it's in here. So I'm going to make a directory called home docker. And I'm going to see if I can do this. Or move, yeah, move docker, home docker. And then do a symlink. This is a really ugly solution. So when I install this, I didn't add enough. I can grow the disk, but it's a big pain. I've got to add curl too. Whoa, what's going on here? System is like doing bad things. Site can't be reached. Oh, I ran out of memory. I only had 2 gigs on the system. So let's do 16,384. And I'll just have to shut it down. I give it 50 gig. That's not going to work though. Start it up. Oh man, this might have hosed things. I might have to reinstall this. That's all right. The whole purpose is to make this repeatable. So this thing has done something. So this is this. You know what? This might have just like completely crap. What's it doing? IO error. Oh, you know what? I think I put it on the wrong disk. Yeah, so I have 2 disks on here. Yep, I put it on the wrong disk. So I need to migrate this disk over. Yeah, so I have 2 drives on here. One of them is very small, and it defaults to try to store things there. So I need to shut this down. I need to stop it. Yeah, so I put this on the small drive on my hypervisor. So I need to move storage to volume 2. So that's what's happening. I'm gonna go get some soda water. Be right back. Oh yeah. Be right back. Gonna wrap up things here pretty soon because I gotta go run. Then I gotta pack a parachute. All right, so I had to move it over to the correct storage. This might have... Oh, didn't. Okay, cool. Started right up. It's 229. There we go. All right. Yeah, root file system is totally full. Where's it for? So it's not var run, var local. Lib. Yeah. There we go. Okay. All right, so let's try that. So sudo docker import. And we want that to Nexus 9KV 936. Oh, cool. All right. So sudo docker image list. That seems to work. Cool. And then here, I just need to change the names to match. So that's fine there. And then this one will be Nexus 9KB 936. This one is CGenOS evolved. I think that should work. That didn't work. Not an absolute path. Okay, I didn't like the sim link. Okay. Going to search results. Okay. So R2 didn't work. That's all right. GNS Evolve will take a minute. So go ahead and do CLab destroy. So I might need to do sudo docker load -i. Oh, that seemed to work. All right, we'll do that then. Yep, that's what it was. Docker load -I. So also B asked a question. Hi, as a new person in tech, what are your thoughts on CCNA after obtaining the Net Plus as an aspiring network automation engineer? Yeah, I would go for the CCNA. CCNA builds a solid foundation in networking. These days, like in network automation, the basics are always going to be important. So you need to know how ARP works, how IP addresses work, how layer 2 forwarding works, spanning tree, the basics of at least of the routing protocols, BGP, OSPF, ISIS. CCNA is going to teach you EIGRP, but I hate EIGRP, mostly because I resent that I have to have another routing protocol in my head that I can't use everywhere. So in my mind, there's 3 routing protocols that you need in the world to do everything you need to do. And that's OSPF, BGP, and ISIS. EIGRP is just a 4th one that I have to learn all the ins and outs of that one, and I can only use it in Cisco networks. So, and it doesn't add really anything that the others don't have. So it's a superfluous one for me. So why is this taking so long? What's going on here? Did I give it enough RAM? It's button right up against it. That's right. 16 gigs is not enough RAM for this topology. So if I do sudo container lab, sudo docker top, or ps stats. Yeah, I think this little combo right here. I've busted out the RAM in this thing. That's the problem with, like, yeah, it actually crashed the system. I'm just gonna stop it. So that's the problem with the virtual machine network operating systems. Like, so Cisco 9KV takes up 6 gigs of RAM, and then Junos Evolve takes up almost 8 gigs of RAM per instance. Whereas the CEOS only takes up less than a gig, so it's way lighter weight. So let's do this. Let's give it 28 gigs. It's way lighter weight. So I had to restart this entire VM with 27 gigs of RAM because it completely choked. It had 16 gigs of RAM. Containerized EOS only takes up 1 gig of RAM per instance, but these two take up 6 and almost 8 respectively, and I ran out of RAM. So console. got to recover. So after you get Net Plus, I would say go for CCNA. Even if you don't work in the Cisco world, if you want to get a job in the networking field, hiring people, they look for the word CCNA in your resume. I think it's probably the most common thing that they look for. CCNP can help, but it's not the bang for the buck isn't really there for CCNP. Because they're going to be looking for CCNA typically. At least, I mean, every place is different, but that's what they're looking for. They're just scouring resumes and they're looking for CCNA. If they don't see it in there, they disallow it. My CCNA is inactive. It's expired. So I used to have a CCNA, but I no longer. I was one of the only people that had the CCNA data center, and that's expired now too. Yeah, so CCNA. So learn networking first, or learn some networking, then you can move into automation, because in order to automate anything, you have to understand how it works. So the first step is to learning how to do it manually, then you learn how to automate it. If you don't do that, it's like running ChatGPT to program without knowing how to program, because you have no idea what you're doing. And then that's where you get into a lot of problems. All right, so sudo system control start code server. There we go. So this should come up. Sudo system control enable code server that user. That'll just make it so that it starts up automatically. Okay, so go to Container Lab, CLab, deploy. To destroy. Okay. So then we'll do deploy. We'll check how much RAM it's using. $79 degrees out. That's not too bad for a run. Okay. That's the R2. It's climbing. And RAM. Look at that, just keeps climbing and climbing and climbing. Super easy. R2 and R3 haven't started. Okay. I think that's enough for today. I'm going to go ahead and cut off the live stream. And I'll see everyone next time.